Hello everyone. In this video, we're going to talk about, or we're going to continue talking about, z-scores and normal distribution type stuff. Okay, so where we ended in the last video, which is hopefully what you watched right before watching this video, or at least soon, is we talked about z-scores, okay, and using z-scores to find probabilities. So we talked about z-scores. Right now, we're going to talk about how to use z-scores to compare things and to find probabilities. Okay, so I have an example here. SAT scores are normally distributed with a mean of 1,500 and a standard deviation of 300. ACT scores are normally distributed with a mean of 21 and a standard deviation of 5. Okay, so a college admissions officer wants to determine which of the two applicants scored better. Okay, Pam scored an 1,800 on the SAT, and Jim scored a 24 on the ACT. So if I have these two normal distributions down below, and I place Pam at 1,800 for the SAT normal distribution on the left, and then Jim at the 24 for the ACT on the right, I can look at them and I can say maybe it looks like Pam did better than Jim, but it's kind of hard for me to compare them separately. So what I can do is I can use a z-score to standardize them and put them all on the same plot. And so that's what I'm going to do. We can't compare these raw scores. We instead need to compare how many standard deviations beyond the mean each observation is. Okay, I know that's weird language, but the interpretation of a z-score is how many standard deviations from the mean an observation is. Okay, so we just need to find z-scores. Whichever one has the highest positive z-scores did better. So Pam, I do 1,800, her score minus the mean divided by the standard deviation. Her z-score is 1. Okay, and Jim, his z-score is 0.6. So who did better? Pam. Okay, and I can put them all together on one graph and see more clearly that Pam has the better score. Okay, even though they took two different tests, we can standardize them onto the same picture to get a better look. Okay, so there's another option that we could use, and that is to find out what percentile of scores each person was in. Okay, so for instance, if Pam scored an 1,800, Jim scored, I think the other person's name is Jim. If Jim scored a 24, okay, I can't compare those apples to apples, but if apples to oranges, but if I said that Pam scored in the 90th percentile of all people who took the SAT, and Jim scored in the 50th percentile of all people who took the ACT, then I can compare apples to apples. Clearly, being in the 90th percentile of an exam is better than the 50th percentile of the other exam. To find a percentile, as we talked about before, is the probability, is the percent of the distribution below a point. And for us, that's the same as saying we want to find the probability that we see a score less than their respective score. Okay, so if I have a person who walks in and I ask what's the probability that this person, without knowing anything about them, gets a score of less than Pam score or Jim's score, I could answer that. Okay, and whichever one has the higher probability, which in turn means the higher percentile, is better. So we'll first start out with Pam and the SAT, and then we'll go with Jim and the ACT. For Pam, we're going to ask the question, what's the probability I see a score of less than 1800? Jim, what's the probability of a score that I see a score of less than 24? So for Pam, I have a normal distribution with a mean of 1500 and a standard deviation of 300, and I'm trying to find the probability that x is less than 1800. Okay, so this is the first example of where we'll see how to use StatCrunch to find this problem. So I'm going to exit out of this, then go to StatCrunch. Okay, so here is StatCrunch. And what we're going to use in StatCrunch is stat, okay, and then down to calculator. So stat, calculator, and then it gives us a bunch of names. Beta, binomial, Cauchy, chi-square, discrete uniform, so on and so forth, all the way down to normal. We're going to use a normal calculator. Okay, so when I click on normal calculator, it gives me this nice picture. Okay, so it gives me a nice picture and then some places to input some stuff. This picture is very nice for making sure that you have the right setup. Okay, so it'll require you to think a little bit about the problem, but if you have the right setup, your picture will look correct. So if we go, if we remember back to our question, we have a normal distribution with a mean of 1500 and a standard deviation of 300. So you enter the mean and standard deviation here, okay? And then down here, you enter the probability statement, okay? So I'm going to find the probability that x is less than 1800. Okay, and so you'll notice that this says less than or equal to. There's no difference in probability. There's no difference between less than and less than or equal to for the normal distribution. Okay, so don't worry that there's an equal sign there for the normal distribution. Of course, if you wanted to find greater than, you could click that, click the pop-up menu there, and you could change it if you wanted greater than. Okay, of course I want less than here. And so when I click compute, or it did it for me anyway, I got 0.8413. Okay, that's the probability that I see a score less than Pam's. So Pam is in the 84th percentile. Okay, so now let's do the same thing for Jim. So back here for Jim, Jim's normal distribution is a mean of 24 and a standard deviation of 5. I'm sorry, mean of 21. This is wrong. It should say mean of 21, standard deviation of 5. And I want to find the probability of getting less than a 24. Okay. And I click compute, and I get that area. You'll see less than 24, which is what I want in the picture, and the number is 0.7257. That's the probability that I see less than a 24. So that means that Jim is in the 72nd percentile, or maybe you can round that up to 73rd percentile. So you see that Pam in the 84th percentile is higher than Jim, who is in the 73rd percentile. Okay, so that's finding probabilities here with the normal calculator. This is going to be your friend. Okay, I'm going to, in future times, ask you the probability that x is between two numbers. You'll see up here that I have standard option, which I'm in now. When I click in between, it gives me the option to put 2 points here, between -1 and 1. Okay, so that's between. Standard is less than or greater than. And you'll see up here it also has an option for them to give the empirical rule ticks. okay, which don't really matter to us, so I'll keep them off. But anyway, there's the normal calculator that's going to help you in future reference. So we'll go back here. Now found those probabilities, 0.841, 0.84 something something, and 0.7257. And so you'll see that Pam has the higher percentile and so did better. Okay, so here's a your turn, and here's where I'll end this video. Okay, I give you a setup about Heinz ketchup bottles and quality control. Then I ask you 2 probability questions, okay? And I want you to use the normal calculator to answer those questions. I'll see you next time.